Over the battlefields of Ukraine, a new tactic has emerged. Low-flying drones drift over the tree line and release a continuous curtain of molten metal, liquid fire, directly onto the ground below. In the 20th century, delivering incendiary weapons on a massive scale required incredible resources. Militaries had to build heavy bombers, fly them deep into enemy territory, and blanket entire areas with unguided munitions. The alternative on the ground meant strapping a tank of volatile liquid to an exposed soldier's back and hoping they could survive an open field long enough to reach their target. Because unleashing large-scale fire was historically either incredibly expensive or highly dangerous for the attacker, the math of modern warfare shifted. Civil defense engineers looked at the data and concluded that the primary threat to surviving a modern war was explosive blasts. That assumption shaped the modern urban environment. When engineers design civil defense structures in modern high-rises today, they build them primarily to withstand kinetic energy, the sheer physical force of flying shrapnel and blast overpressure. You can see this in safe rooms like Israel's Mammods. They rely on dense, reinforced concrete cores to repel external explosive forces. But a highly maneuverable drone completely bypasses the need for raw blast force. It flies past the heavy defenses and delivers extreme, localized heat directly to a building's most vulnerable points. By engineering our buildings to resist explosions, we inadvertently created environments that are wholly unprepared for a sustained thermal catastrophe. The payload is thermite, aluminum powder and iron oxide. When triggered, it undergoes a rapid exothermic reaction, instantly reaching 2400 degrees Celsius, melting most metals. Because iron oxide contains its own oxygen, the thermite continues burning even when completely submerged in water. To deliver this chemistry, operators mount containers of the mixture to commercially available FPV multi-rotor drones. They fly them at low altitudes, remotely initiating the reaction right above the target. Thermite transforms a disposable piece of consumer electronics into a self-sustaining thermal event that defies traditional containment efforts. On the battlefield, the primary tactical advantage is the rapid denial of concealment. A single pass easily burns away camouflage nets, dry brush, and tree lines hiding infantry positions. It is equally effective against hardware. A concentrated drop of burning thermite can melt straight through 4 millimeters of steel in under 10 seconds. The aftermath leaves heavily armored vehicles destroyed. The intense heat completely guts the interior, leaving only a pool of solidified metal where the engine was. This thermal capability is pivoting towards civilian infrastructure. Long-distance loitering munitions create immense fire hazards, arriving with dozens of liters of unspent fuel. The exact same thermal efficiency that melts a heavily armored tank makes a civilian building defenseless against deep-strike drone attacks. When these drones hit an urban environment, direct impacts on apartment balconies and roofs cause immediate ignition of structural elements. In this image, you can see the dense, concentrated fire localized entirely on the upper floors. This diagram illustrates the immediate danger. Standard internal staircases begin to act like exhaust shafts, funneling toxic smoke rapidly through the building and blocking the only route of escape. Even the designated safe room fails. The reinforced walls remain intact, but the space becomes a thermal trap. Internal oxygen levels drop to zero, replaced by carbon monoxide, leading to rapid asphyxiation. Eventually, the critical heating reaches the concrete core itself, causing the material to degrade and compromising the structural integrity of the entire building. In the face of an incendiary drone strike, the exact architectural features designed to keep a kinetic blast out will fatally lock the heat and smoke in. The Geneva Conventions expressly prohibit the use of incendiary weapons against civilians, but the reality on the ground in modern conflicts shows these laws are regularly bypassed. This leaves massive residential blocks vulnerable to secondary fires, resulting in blackened, structurally compromised facades spanning multiple floors. This presents an urgent engineering challenge. Architects and civil defense planners must design entirely new external rescue systems and build alternative evacuation methods into the blueprints of future high-rises. The ability of cheap drones to deliver intense, sustained heat has revealed a critical gap in how we build. Surviving the initial blast is only a partial success if the resulting fire makes the building itself lethal.